You've seen how to add, subtract, and multiply integers. In all these cases, the result is another integer. In this video, we extend into dividing integers. In some cases, the result is another integer, but we will also look at cases where the result is not an integer. Let's start with an example. There are 15 pizzas being divided among 3 classrooms. How many pizzas does each classroom get? Use an array to solve the problem. Use the Cartesian coordinate system to model the array. Since both integers are positive, model the array in quadrant 1. We start with a 15 by 1 array. Our goal is to divide this array into 3 equal parts. A 5 by 3 array has 15 squares. The 3 columns represent the 3 classrooms, and the 5 rows represent the number of pizzas each classroom will get. Let's look at another example. How can you use arrays to divide 2 integers, one positive and one negative? Use arrays to divide these 2 integers, -8 divided by 2. We are looking to divide -8 by 2 using arrays. In the previous example, you saw that an array is an arrangement of squares that models the numbers being multiplied, and we can use the Cartesian plane to model the division. The 4 quadrants of the Cartesian coordinate system can be used to model division using arrays. Let's start by creating an 8 by 1 rectangle along the negative x-axis and positive y-axis, as shown. We want to divide this into 2 equal parts. This array shows -8 divided by 2. The location of this array on quadrant 2 shows that the result is -4. We can generalize this to say that a negative divided by a positive is negative. Let's look at another example. How can you use a number line to divide integers? Use a number line to divide these integers. 6 divided by -2 and -6 divided by -2. Let's start with 6 divided by -2. Graph the number being divided on the number line. Divide by the absolute value of the second number. If the divisor is negative, flip to the opposite term. Repeat the same process for the other expression. We start with -6, then divide by the absolute value of this term to get -3. Because this term is negative, flip to the opposite of this term. The result is 3. Let's look at a final example. If you divide one integer into another, is a result always an integer? Why or why not? With addition, subtraction, and multiplication of integers, the result is another integer. But it isn't always the case with division. Quotients can be integers, but sometimes the quotients are non-integers. The non-integer quotients form a broader set of numbers called rational numbers.